our team and our research. I hope you enjoy this time. So my name is Sunwoo Kim. I'm currently the director of Beyond G Global Innovation Center. This is the National Research Center funded by the Ministry of Science and Communication. And we were established last year as a core national research center of our nation. So we will be receiving the funding for the next, we started last year, so it will be extending the next 9 years. So it's like basically 10-year national funding. So we are targeting, I'm going to briefly talk about a little bit of our research center and go into the discussion of integrated sensing and communication. So our research team consists of 3 groups. The first group is for hyper-resolution sensing. The second group is the hyper-connectivity communication. The third group is the hyper-intelligence system. So as you probably know, in communication system, sensing is another very important core direction for 6G. So in our team, in the first group, we are especially putting our special effort for the wireless sensing technology, which will be combined with the connectivity communication technologies, which will be developed in group 2. And eventually, we like to make the realistic demonstration for this, putting communication and sensing all together. That will be carried out in the group 3. So that is basically the structure of research center. So hopefully in the end, we want to show you something meaningful and impactful research result for the next generation and communication system. So this is the team members of our research center, and we are extending our research network toward the various research institutions worldwide. We are obviously, the research these days requires a lot of global collaboration. So hopefully everybody here watching this will be connected and work together for something very good. So this is something we are envisioning in the, let's say, 10 years later. So a little bit complicated. So if you think about what will happen 10 years later, a lot of things will be run by artificial intelligence, and basically we like to make the network, mobile network, intelligent. To have that system intelligent, that system will need a lot of data, right? So the communication system will not only transfer data, but also sense the whole environment. So it's like a human being. We have eyes, ears, and we can sense the environment. So we want to make the communication system such that the system is sensing the environment and collecting all the useful information from the neighborhood. And that, with that information, we like to make the system very intelligent. So for that sake, we will have different technologies. We'll have the very strong sensing technology, not only with the classical radio signal, but also with the quantum technology as well. So we like to put that in the, let's say, if you see this, we have somewhat large scale, I'm going to say the AI server, okay? So this AI server will process those bunch of information and make the network intelligent, and then based on that intelligence, will improve the communication network to another level. So that's what we are envisioning. In the course of doing it, well, we hear a lot of digital twin these days. So digital twin means basically we are copying the whole physical world and then make the digital twin, and then we'll embed it in the communication system. So with that digital twin, the communication system will be eventually very intelligent. And then with that, well, we use a lot of graphical processing unit, GPU, and with that help, we will have very intelligent communication network. So that's basically what we are envisioning with our national funding. So this is basically a brief overview of our research center, which we started last year. So it's been 1 year, so we'll continue working hard, and then we'll need your support. We'll need international collaboration. So whenever you feel like to do something with somebody in Korea, feel free to contact me. We are open to everybody here. And hopefully we work together and develop something nice. Okay, so now I have 14 minutes. Clearly, I see the time left. So in the next 14 minutes, I'm going to spend some time to talk about integrated sensing and communication, which is kind of my research theme. And of course, integrated sensing and communication is becoming very important these days when we work toward 6G communication. And I'm going to talk about this technology. So if you look at the first slide, by the way, my slide is not very fancy, unlike other speakers today. So excuse me, this is my best. If I could have get some help from the designer, I could have brought up more well-prepared slide, but sorry about that. I'm from university. I'm a university professor, so this is the best I can do. So, well, we've been talking about localization many years. So I started my localization research early 2000. So it's been already 25 years. So localization positioning is not anymore something strange to all of you. So it's becoming very well known to a lot of people. In communication system, I think the next generation communication system will get a lot of benefit from the localization technology. It is because the communication system is becoming more and more and highly directive, meaning that the transmitted signal is no longer omnidirectional. So as we increase our frequency, the directivity increases, and you see a lot of reflections. And oftentimes, the signal does not propagate through the wall. So the communication system will experience very different propagation condition in the next generation communication system. In that sense, knowing the location of receiver is becoming very important. If we know the location of receiver, we can make the strong directivity toward the receiver, and then we can effectively, which means that we can use something called antenna array. By using the antenna array, we generate very strong beam toward the destination, toward the receiver, and then we can have very efficient data transmission. So to do that, we'll require very strong positioning technology. With that positioning technology, we'll be able to locate the receiver with high precision, and then we'll make the very strong beam toward the destination. And so this is the figure that I generate. So if you have very good positioning technology, with that positioning technology, we can do super directivity location. We can generate super directivity location awareness, which will be helping the communication system. And again, if you have good communication system, anyway, positioning is based on the communication system. So if you have good communication system, that will naturally improve the positioning performance. Then we can draw this kind of arrow. So good positioning will help communication, and good communication will help positioning. So we make somewhat very friendly and meaningful supportive feedback loop with these two components in the communication system. This is very conceptual, and the question remaining is how we really achieve this kind of concept in communication system. So I believe the question will be answered by the research, which is called integrated sensing and communication. And that is, in fact, I believe it will be very important, not only for personal communication, but also for the applications like self-driving cars, robots, drones. I'm speaking about like things, Internet of Things. A lot of different objects will be equipped with communication system. So that is basically why we are putting a lot of effort for integrated sensing and communication. Probably some years later, when we have robots, intelligent cars, and when they need to communicate each other, then integrated sensing and communication will play some important roles. And that's what I'm hoping for. So I'm going to give you some brief introduction about integrated sensing and communication. So we like to put two parts together. There is one component is sensing, the other component is communication. Communication has been there for many years since the Shannon theory. The history goes back to 1947, 48 something. And historically, communication system didn't really care much about sensing. And sensing part is, there was another part of group around the world. There are people working on radar. Okay, so radar was sort of very different from communication part. Communication people don't understand radar very much. Radar people don't understand communication very much. So it's two separate tasks, very separate function. The roles are different, and the systems are very different. But when we move toward the 6G, we like to put them together. We like to have sensing integrated into the communication system, and that is what we are working for. But unfortunately, these two tasks are very different. Communication is all about transmitting information from one spot to another spot. But radar system, if you look at it, there's no interest, no need for information transfer. The radar system only wants to detect the target. So basically the goal is different. So the question is how we will combine these two together, and that will generate a lot of research problems. How we design the waveform, how we allocate our resources to communication and sensing. We will send communication sensing together, or we will split. How will we split, etc., etc., etc. So that's all kinds of different research problems is following. And obviously a lot of people, not only academia, but also I believe industries are paying a lot of attention to this kind of research topics. So there are different advantages for integrated sensing and communication. We can use the resource efficiently. Obviously, we can improve the communication performance. We can make the network intelligent, and we can improve the security, of course, and we can support the emerging applications like notably autonomous systems and augmented and virtual reality and healthcare, etc. So that's basically the advantages that we are hoping for. And if you talk about how the sensing is becoming possible and feasible in 6G, I can answer that by showing this slide. So classically, if you in the communication, we do things like channel estimation. We have to estimate the channel, and by estimating the channel, we recover the distorted signal at the receiver. So without channel estimation, we cannot recover the signal, distorted signal. We will not be able to receive the information. So anyway, we will have to do the channel estimation. These days, with the high performance communication, high performance circuits, semiconductor, and computer, whatever we use for at the receiving side, the performance is, unbelievable. So with the high performance communication, the channel estimation is becoming more and more accurate. And if you look at the channel, basically wireless channel is the result of all kinds of reflections and scatterings generated by the actual environment. If you assume that there is a wall, and that wall will obviously generate a reflection. So if you look at the channel closely, from the channel we can understand the environment at a certain level. So that's why now with the channel estimation, we'll be able to generate or reconstruct the environment, and we can do the sensing, okay? So that's basically what we are doing these days. And in the past years, if you look at the robotics, there were a technology called camera slam, LiDAR slam kind of thing. So if you have this kind of robot running in the indoor on the floor, and they will have the camera on top of it or LiDAR on top of it, it rolls around and then sense the environment. That is basically done with the light. Light is it has strong resolution for sensing, as if we see everything with our eyes. But if you look at the communication system, the signal frequency is increasing. Nowadays, we are talking about in 6G, we talk about 7 gigahertz, 8 gigahertz. Previously, we also talked about 28 gigahertz. For autonomous system, autonomous vehicle, we use 77 gigahertz. We also talk about sub-terahertz signal, 140, 150 gigahertz signal. So when signal frequency goes up, the sensing resolution becomes very high. So we can think about, maybe we can do sensing with the radio signal. So with that concept, we come up with the idea of sensing, doing the simultaneous localization mapping with the radio signal, and that's what we call radio slam. Okay, so this is some kind of sensing technique we can incorporate into the communication system. We can do the sensing and communication all together with the communication signal. And of course, we still have LiDAR, we still have camera, so we can, now people talk about multimodal sensing, but what is important is that we can no longer use the signal only for communication. We'll use the signal also for radio sensing. So that's important message that I'd like to give you today. So if you look at the scenario, there is a base station. It sends out the signal downlink. The signal will be reflected by the wall and receive the vehicle. And when the vehicle receives the signal, it will do some receiving processing, and will estimate the reflection point or scattering point. We can somehow generate the environment. So that's what radio slam do. So I have some animation, but I will pass. And of course, this is possible because the environment is geometrically related to the channel parameters. So once we have the good channel parameters estimated, and that can be related into the environment locations. So that's how we do the sensing. Some mathematics. I'm gonna pass. So since I have 30 seconds left, I'm going to directly go to the conclusions. These are some ongoing research effort developing the hardware prototyping for integrated sensing and communication that is being developed in our research center. We use the 28 gigahertz and bandwidth spanning over 800 megahertz. So this is the conclusion. So I believe the communication is moving. We are shifting to another era. And the 6G will, people working on 6G is paying a lot of attention on integrated sensing and communication. And of course, there are a lot of different good sensors, but anyway, communication signal is also used for sensing. So if we integrate them together, and hopefully we generate good thing, and I don't know, I mean, when time comes, it will become very useful, and then that will be also help the autonomous system like robots and autonomous driving cars, etc., etc., etc. So that's what we are hoping for 6G communication. Thank you very much.